Hello, everyone. Welcome to another episode of Cuda Education. Today, we want to continue learning about the modern renderer application. And basically, I have links down below for the application. We have a scene here with buildings, lights, architecture, fog, all of that good stuff. We are most interested in this particular scene where there's no volumetric scattering. So the volumetric scattering is what enables this fog stuff. But what I'm more interested in is this particular one where we don't have the volumetric scattering, right? It's a setting in the application. I believe it's when you press number 3, which is ambient occlusion setting. But from where I stand and what where I'm at right now, I want to get rid of the volumetric scattering because that's a whole nother conversation. The purpose of this episode is to talk about lighting. So we're doing all things lighting, okay? So we have many lights that is lighting up the scene, okay? And we are trying to sort of get an idea of how the lay of the land and how all of this works, okay? So that is the purpose of this episode. And what I'm going to do, first of all, is we are going to what we're going to do is we're going to run the application now in my modified code, and we still have our situation here, but I want to get rid of the volumetric scattering. When you get rid of the volumetric scattering, we have pitch darkness, okay? We have pitch darkness. And then what we're trying to do now is that we want to no, not this. So what we want to do is just turn on specific lights in the application. Now, just to anchor you guys on where we are in the application. So it's a modern renderer application. We're in renderer. We're in the shaders file. And then we're in the APL lighting common header file, .h file, okay? So this is where we are in terms of, a lot of the modifications that I'm going to do right now. Okay. And we're gonna dissect a couple of the terms that are used in this application to sort of see the lay of the land and how things work and all that stuff, right? So that's the task for this video, and it will anchor us into investigating further later. The first one that I want to go over is disabling the directional sun term. Okay, so there is sort of a pseudo sun, if you will, that's like coming from up above, that's lighting the scene. Okay, and right now I have that term disabled. So right now I have result equals 0.0h. Now we are in the lighting shader function of this file. We're not gonna get into all the other stuff, but we're in the lighting shader function of this file, and basically, reusable function for applying lighting includes overrides for debug visualization if the genable debug view function constant is set to be true. But so we have this lighting shader function here. And basically what it does, so it starts here and it has a bunch of parameters, and then it does processing within these brackets. So we have sort of the signature here of the function, lighting shader, and then below we have all of the information associated with this particular function. Notice that it goes all the way down to here. Okay, so we start up here. We start up here in terms of its definition, and it goes all the way down here. All right. So, what I'm going to do is toggle a couple of items inside of this function, and it's going to change what we see in the application. Now, again, we're just dealing with lighting, right? We're in the Apple renderer, shaders, APL lighting common header file, H file, and we're in the lighting shader function, which for the most part, for all intents and purposes, um, this is what is in charge of, all the lighting in our scene. Okay. So let's start with the directional sun term. Okay. So right now I've disabled the directional sun term. And what I'm going to do is I'm going to enable the directional sun term in our processing. Now, what I think is happening here is that, we're basically building up this result variable, right? So we have all this going on here, and then we have this result variable here that's being built up. So if we go all the way down to the end, we have return result, okay? So all things affecting what we do is being attached to result, okay? Now the thing is that if I if I don't do anything with this set of if I don't do anything with this set of this block of instructions, if I just do result equals 0.0h, then I skip out this directional sun term, right? But we're going to put in our directional sun term to see exactly what happens in the application. So let us run it and see what happens. Now, of course, I have to toggle this thing because the volumetric scattering stuff is a whole nother cup of tea, and it messes up everything that I'm doing, right? But notice now that with the directional sun term, which is somewhere up here, we can't see the sun, but we know that it's somewhere up here, coming from this direction based on how everything is done. It's coming from sort of this direction, okay? We don't really see the sun, but we know it's coming from this direction, okay? And that's that's sort of where we're having the directional sun. And yeah, you could see the effect of all of this on the application. So, we could see where we're adding in everything, and now we have a sort of a sun term coming into the scene. Now all lights are off, everything is off. We could this is a telltale sign that the sun is coming from somewhere up in this direction, right? Because we could see the sheen here. We don't actually see a sun, but we do have this directional sun term. Okay. So obviously if we take back out the term and we run again, right, we basically get pitch black, okay? So we don't have any lighting whatsoever at all, okay? So that is our that is our directional sun term situation. Let's now move on to, and again, it's all part of the lighting shader function, right? So we're taking all this stuff and then we're doing processing with it. Let us move on to the point lights. Okay, so I believe I went over this in the previous video, but we're gonna do it here. Okay, right, we still have to add this 0.0h here. because I believe it will error out if I don't add this in here. Or actually, it does it? I believe it does. I'm not gonna try it here. Okay, so then we have our point lights. Okay, so let us put back in our point lights. So right now I have the point lights as disabled, but I'm gonna put back in the point lights. Okay, so let us put back in our point lights, and we are going to see what happens when we put back in our point lights. Okay, so when we get rid of volumetric scattering, we see that we have some point lights. Not exactly what I was expecting actually. I know the lights on here was supposed to be what it was, but we do have this term here. I actually was thinking of something different with the point lights, but anyway, we do have some point lights, okay? For what it's worth, right? This is sort of the point lights function, and it's showing the point lights. The thing about it is, okay, so we have our point lights, but all right, we'll come back to this in a second. Let us now, instead of doing the point lights, let us do the spotlights. Okay, so we're still in our light shader function. The point lights basically and the spotlights, it's you're looping over indices of a light index. Okay, that's as far as we're gonna go for now. We're looping over light indexes, and if I say you know point light count is 0, I skip the looping over of all of these indexes, right? So basically this loop is disabled, and we don't get anything. So if we run where we disable the point light system, I mean the point light indices or the loop, and we don't go over the loop. Oh, sorry, I have to actually have to so if we disable the for loop, basically we get complete darkness, right? So we get that. So let us now we're going to enable the spotlight. So just like with point lights, now we have the spotlights. Okay, so when we run the spotlight, we're gonna get the spotlights. Okay, so let us get rid of this, and now we have our spotlights. Okay, all right, so I get it now. I didn't actually do this. I didn't actually do this stuff with everything dark, so it's actually my first run of doing it with everything dark. So the point light and the spotlights are basically, they're not showing the bulbs themselves, they're showing the actual cast of the light. Well, at least for the spotlight. Okay, so for the spotlight, we're seeing the cast of the light itself. Okay, do we see anything else when we look elsewhere? Okay, so we do have some spotlights. Okay, mainly it's the ones that lighting up the street. Okay, so we do have the one lighting up the street, and then there's one like lighting up the flowers and stuff. For all you architecture guys out there, creative guys, you will appreciate something like this. Okay, but that is the spotlight. I want to spend a little bit more time here because this is very important. So again, it's instead of basically saying the spotlight count is 0, which would disable this for loop here, we're actually going to climb through all of the indices of the spotlights, and it's going to show, right? But I do want to spend some time with this a little bit more. Now, one of the things with the point light, which I'm a little bit disappointed in, is that with the point lights, we have with the point lights, I see that we have oh, I gotta put this back in, right? So with the point lights, I see that we have the cast of the actually no, this is actually what I wanted. Sorry guys, I know I'm bouncing around. But this is actually there. This is a good thing, right? So the light bulbs themselves don't light up, but the cast of the light lights up. So obviously this should be a lit bulb and it will show the cast of the light, right? That's my layman's term of what we're seeing, right? So we have all these lights and we have the cast of the lights, okay? So, when we look at the scene, we have the cast of the point lights, right? If we go and if we also enable our spotlights, right, we're going to get the cast of the spotlights and the cast of the point lights, right? So we have the cast of the spotlights and the cast of the point lights, okay? Now, there's a very interesting term that we have to consider in all of this, okay? So, there's an interesting term that affects all of this, okay? So we're seeing that the light bulbs themselves aren't being lit up, but the cast of the light is being lit up, okay? So what we want to do now is we want to light up. So we actually want to light up the light bulbs, okay? So it's not cool that we just have the cast of the light. We actually, to make our scene realistic, we actually want to light the light bulbs, right? So we have the street lights here. That's, these lights, this cast is coming from somewhere, right? But we have to light up the light bulb, okay? So in order to light up the light bulb, what we have to do is we have to we have to run a term called the emissive terms, okay? So emissive, emit lights from light bulb. So that's this term right here. So we have our point light system, we have our spotlight system, and now we want to light up the light bulbs. Just for, just to take things one step at a time, I'm just gonna light up the spotlights for now, okay? So we're going to build into our result variable that we want to do this emissive term. Now, this emissive term is something that, I just learned myself. I understood. I read about it. It said, oh, it's for materials and things that emit objects that emit radiance or something like that. That was like, I'm like, okay, what the hell does that mean? So in this example now, we're going to see exactly what it means, right? So we are going to now run our application with the emissive stuff turned on, right? The spotlights. So notice now that with the spotlights turned on, we have objects that and it's all objects. It's not just the spot objects. It's all objects. All objects, all light bulbs now are turned on. Now, the thing about it is that I only have the spotlight stuff turned on. So the cast only makes sense for the spotlight stuff. So these are spotlights and we have our cast. This is a spotlight, we have our cast. For the point light stuff, the bulb is lit, but we don't have a cast. Okay? Makes sense because we haven't turned on the cast for the point lights. But for the spotlights, this works. And it makes sense, right? Actually, if we go up top, maybe if I go, are these spotlights over here? These spotlights over here. What are these guys? Okay, these I guess are point lights, or maybe not. I don't know. What is this? Okay, no, these are spotlights. Okay, so we have the cast and we have the spotlights, right? It's on the red awning, right? And we have our spotlights here. Okay, so that is what did we do, guys? What did we do? We turned on emissive, so all light bulbs are showing, but we only have the spotlights turned on also, right? The cast for the spotlights. Let's do the cast for the point lights. So if we turn on the cast for the point lights, right, we are going to get now the cast for the spotlights. Okay. Now for these guys up here, it's kind of hard to see because it's just small. For these guys, it's hard to see because it's kind of like in the middle of the air, and it doesn't really have anything to reflect its radiance. But this guy you could see, right? You could see that it's thing. These guys, you could kind of see it a little bit, like it's affecting the wire, right? And if we turn it back off, we'll see that. If we turn it back off, we'll see that the wire doesn't light up. The wire doesn't light up anymore, right? So you see the wire doesn't light up anymore. It's not doing radiance. And the building doesn't light up, and nothing, it doesn't light up. And of course, these guys don't light up, right? Oops. You guys get the picture. I don't know what I'm doing. It's too dark. It's too dark, guys. It's too dark. All right. So, you know what? I'll just run it again. So, it's too dark. Okay, right? So, right, these don't light up or anything. Okay? All right. So, we have made progress in this regard. So we have our point lights, we have our spotlights, we have our emissive results. So again, all we're doing is we're building this result variable, right? Everything lives in this result variable. Let's turn everything back off. So we're turning emissive off. We're disabling the point lights. We're disabling the spotlights, right? And we are disabling point lights, disabling spotlights. We are disabling point light spotlight, and we're disabling emissive point light spotlight. Okay. Let me run the application to make sure that I've disabled everything, right? So everything is disabled, right? I don't see any light anywhere. Okay. Now what we want to do is we want to run this thing called IBL environment lighting. Okay, so this is environment lighting, which is like environment lighting. What's that? All right, let's see what it is. Okay, so we're going to run environment lighting now to see what that's all about. Okay. So environment lighting is environment lighting. It's sort of environment lighting. You guys look that up, okay? I'm not even gonna attempt to explain what environment lighting is. It's this. Okay? It's sort of, I don't know. It's just the natural lighting of the environment. It's not necessarily coming from the sun. It's not necessarily coming from the object itself. It's just sort of plain vanilla environment lighting, okay? And that's what it is, right? That's what it is. It's environment lighting, right? It's environment lighting. It's environment lighting. I can't really explain it to you any much more different than that. Okay, it's environment lighting. But this is the term that is used for environment lighting. I mean, you guys have seen this, especially if there's like a power cut, a blackout. You guys have kind of had this vibe where it's not necessarily the sun and it's not necessarily any light bulbs or anything, but we do have this environment lighting, right? All in the effort to make our thing look real. Now, what we can do is we're going to turn on environment lighting, but we're also going to let's turn on directional sun term. Okay, so we're going to turn on directional sun term. Okay, and we're going to see what we get with that. So we have our directional sun term. So we have environment lighting and our directional sun term. Okay, so now we have this. So it's a little bit brighter, okay? We can't complain about that. It's a little bit brighter. We do have, we do have, a little bit more, ambiance in the place. I don't know what's going on with this guy up here, but okay. We'll leave that alone. It's an antenna. But we have our directional sun term. And we kind of know what direction because we could see this is a pole here and its shadow is being cast that way. Same thing with this one over here. So we have our directional sun term. All right, let us disable some stuff. So we're disabling directional sun term. We're disabling IBL environment lighting. Aha. Now, okay, right. All right, so now we want to talk about sky color, which let us see what that's about. So we have complete darkness, right? The sky color doesn't show. We have complete darkness, so we're good there. So let us now put in sky color and see what happens when we have sky color. Okay. So with sky color now, we see that we have the color of the sky. Now, I did do a previous episode where we painted the sky red, and that was, that was that. But we have basically sky color, okay? But the sky color doesn't really cast any light on anything. It's just the sky color, okay? So that is the sky color. No big deal. If we use the sky color and let's say for just to be easy, we do the sky color and the directional sun term for relevance control. We see that we have a little bit more of a realistic scene, right? We still get hard shadows and stuff, but we do have a little bit more of a realistic scene, okay? So that is that. Let us take back out our directional sun term, and we are going to let's take out sky color. And I think that's it. That's it for all that we want to do. There is this turning off all direct lighting, but I don't think you know it's relevant for what we're trying to do right now. So all right, let us put everything together now, guys. So we're gonna put everything together. Again, we have our lighting shader function with all its parameters, and then we massage it into the result. We massage it into the result variable, and we return that down here. There's also a visualized light count, which I will do at the end. But for now, let us go through the process of putting back everything into the application. So we're putting in back our sun term, directional sun term. Okay, we're gonna put back in our environment lighting. Um, what is this? Hold on. What is this? Notice that I think this is what initializes the result variable. So that's why every time I don't do anything with this, it gets crazy. What is this AO sample? Okay, that doesn't do anything for now. Okay, so we'll leave that alone. All right, so we'll put back in our directional sun term, right? We're putting back in our environment lighting. We're putting back in, we're going to have irradiance coming from the light bulbs themselves, right? Actually, you know what? Let us do this. Let us, so we have everything disabled. Let's just make sure I have everything disabled. Okay, we have everything disabled. Let us just emit from the light bulbs. Emit lights from light bulbs, okay? I just want to see something. Okay, so now we just have our light bulbs, okay? We just have our light bulbs, nothing else. Okay? All right. I think we did this before, but I just wanted to do it again. Okay. All right. So yeah, let's get back to where we were. So we're going to put in our directional sun term. We're going to put in our environment lighting. We're going to put in we're going to emit stuff from, radiance from the light bulbs itself. We are going to put in our point, the cast of the point lights. We're going to put in the cast of the spotlights. We're going to put in the sky color, right? And then we should have our application back, right? So we have our application back, okay? We have the point lights, we have the spotlights, we have the lights coming onto the street, we have the sky color, we have the bulbs emitting stuff. We have environment lighting. We have what else? um, yeah, we basically have everything. Okay. And yeah, look at that, right? That's pretty cool. Okay, so this is architecture for you guys. For you guys that are creatively inclined, this is the stuff that you want to be playing around with. Did I miss anything? We have our directional sun term. We have our environment lighting. Let's see if this AO sample thing changes stuff. Okay. Does it make it all right, it does make it a little bit more dreamy, right? It makes it a little bit more nicer, would you say? Um, let's take it out and see what we get. Yeah, I think it's a little less, I mean, it's a little more rough around the edges, but I just can't see what's going on really. I believe it's, yeah, like you could see the tile. The tile is not as it's not as nice. Let's put it back in and see what we get. Yeah, it's a little bit more cleaner. You see the tiles have a little bit more of a more of a texture to them. So that's what the AO sample is. I guess I'll do another episode talking about that. But it does look a little bit more richer if you ask me. We'll do another cycle of it. Um, just to see what happens. Yeah, I think the walls are a little bit more rougher. This doesn't have as much thing. This still looks pretty rich though, but yeah, the awning, it doesn't look as crisp. It looks more like paste. You see, it looks more like paste. If we put it back in and then we run it, we see that this is a little bit more richer. The walls are a little come alive a little bit more, but I want to see the awnings. Yeah, slightly more. It doesn't look as pasty, right? Doesn't look as pasty. Yeah, you see, it kind of does look more pasty. Ambient occlusion, guys. So anyway, we'll leave it back in for good measure. So that's what all of this is about. We'll have to dive into the math at some point, I'm sure. Like all of this stuff right here, we're gonna have to dive into that stuff, guys. But I don't want to bore you from the start. Um, I don't know what this spotlight shadows thing is. Um, So the last thing I want to do with this video is I want to show you the light count. Okay, so we have, as far as I'm concerned, we have everything on, right? We have everything on. We have everything on. But what I want to do is I want to visualize sort of the effect of this light. Okay, so when we have this light, no, I think I did it wrong. You know what? I'll save this for another episode. Should I? Yeah, I'll save this for another episode. I might have done it in a previous episode too. Oh, I know what happened. I forgot to comment this out. Right. So here we go, guys. So this is the halo of all the lights. So remember, guys, notice that we had a bulb here, and we had a bulb there, and we had all of this stuff going on. We had the line with the radiance from the spotlights, from the point lights. We had a thing going on to the walls. So this is basically showing you what happens, like what's the effect of these lights in sort of a black and white instance. What is the radiance doing to all of these lights, right? And we could see all that's going on here, all that's going on here, and it's really it really just shows you what is happening. So anyway, guys, actually I'll just do I'll just do that. Okay, so if I do that, I should be able to get back what I originally think, right? I want to do one other thing, actually. I want to just comment out the results so we don't return anything. What happens if we don't return anything, right? Let's see what happens if we don't return anything. We get this, which I don't know what this is. This is some windows. What is inside of the windows? Let's look. Dum da dum dum dum. Listen, I should be a horror movie director, man. All right. We don't return. This is what happens when you don't return anything, guys. You get this. Right. Which is whatever it is, okay? You get this. So anyway, guys, this episode is over. A couple of announcements. Let's get back to sanity. Couple of announcements. First of all, Xcode 26.3, which allows you to do the coding intelligence, agentic coding stuff. It is now officially been updated to, not updated. It's been released onto the App Store. So on the regular Apple App Store, when you download Xcode, you're going to download Xcode 26.3. Now, why is that important? 26.3 is the Xcode that allows you to do agentic coding. Okay, so basically you press this button here, and then you have an interface where you could basically ask stuff about the code that's written. You could ask for information, and it is context aware of the project that you're in. So it's context aware of all that's going on here and all the files and everything. So it is now on the default regular Apple App Store. So you don't need to have an Apple developer account. in order to log into the Apple developer portal to download the beta release or the release candidate, whatever, right? It is now the normal, it's a new Xcode that's normally available to everyone. Only requirements is that you have the latest Mac OS operating system. You have Apple Intelligence enabled in the operating system. You have, you have Apple Silicon. And at least for my case, you have a paid subscription to OpenAI. Now, OpenAI has their model Codex, which is the coding specific branch of the the AI model. So it's not just ChatGPT, it's Codex. Even though you can use ChatGPT in it too, I think. But it's Codex for OpenAI. So you have a paid subscription to that, or you have Claude. So Claude is Anthropic's coding model. Now you're also able to import your other AI models. So what they call MPC. I don't know, model provider coding or something, MPC. But anyway, so like if you have Gemini, if you have Google Gemini, you just put in a key and you could attach it. But by default, the interface, allows you to attach your Claude or your Codex. Claude is Anthropic's thing and Codex is OpenAI's thing. So that is now freely available. I mean, that's the Xcode 26.3 is now readily available on the App Store. You do not need an Apple developer account. The previous version 26.2 did not have the coding intelligence interface and all that stuff. And yeah, this code is freely available on it's freely available. I have the links down below for it. Learn Apple Metal in 2026. We're already basically in March already. We're basically in March, guys. We are the year is moving by fast. We're almost done with the first quarter. So, get started learning Apple Metal. It is an important technology that is relevant for the future for those that are interested in computer graphics, all that stuff. This is Metal 4, so you will need modern hardware to run this example. It needs to be Apple Silicon and all that. It has to be able to run Metal 4. That's pretty much it, guys. Thank you for watching. Like, subscribe, tell your friends. Anyone that's artistically inclined, get them involved in this stuff. You could as you can see here, you could really get creative with this stuff and create something new that the world has never seen before. Have a great day, guys.